I want to talk about all the things that I had to learn on the job as opposed to learning in school for software development. When you're in school, you're going to learn things like programming, algorithms, math. You might learn databases, networking, depending on what major you are. But you never really branch that much into like a lot of system design, and you never really get into deployments. You never really get into monitoring, um, just troubleshooting, debugging, and honestly finding business value out of the thing that you're making. Sometimes when you delve too far into the sciences, you can kind of lose sight of the bigger picture. And for me, the thing that I had to learn on the job since doing this full time is to always think of the bigger picture in terms of how your application fits into the business and how it adds value, and really what it's supposed to be doing. Because you know we all like to use the latest and greatest technology in whatever language we want to, but there has to be a value to what we decide to do, right? We can't just arbitrarily just decide to pick and do whatever we want, right? There has to be a case that we have to make that justifies why we need to upgrade something, why we need to use this technology versus that technology, right? There has to be a business case for whatever action you do. And that's something that I've had to learn on the job, and especially becoming, getting higher and higher up the ladder, so to speak. I've learned this more and more. When I was first starting out, the only thing I was really concerned about was like my code quality, right? I was super concerned about like the small nitpicky things like, oh, should I do an early return here out of this method? Should I make this a one line if statement? I was concerned about all that stuff, and in the grand scheme of things, that stuff does not matter at all. And now looking back at you know how I used to code, all the stuff that I used to care about, I could care less about now. I don't really care that much about writing like super like you know pure functions that do one singular thing, because sometimes you just can't write them that way. And sometimes it just frankly does not matter if you nest an if statement. And sometimes it just does not matter if you write something in one line compared to three lines. And it doesn't matter if you use curly braces or if you don't use curly braces. That stuff truly does not matter beyond the subjective viewpoint of the reader of your pull request, in my opinion. And for me, the thing that I also had to learn on the job was I had to learn that when I push code out to production, I'm responsible for how it performs, right? I'm responsible for if something breaks, if something goes wrong. And that raises the question, how do I know something went wrong? How do I know it's performing like it should? Are there tests that ran to validate the code that I put through? Is there some kind of monitoring that's in place that's going to alert me of a problem? Are there logs that I have to be reading in order to figure out if there is a problem and if I need to roll back code? These are all the things that I was unaware of coming into this career. And that I wish that there was some like I wish I had been taught this better, because it's so important and it's so foundational to just not only working in this job but advancing in this job. Because when you write code and you push it out to production, you have to always be ready to roll that code back, right? Because let's face it, nobody's perfect, and we're always going to push out bugs whether we want to or not. That's just human nature. And we always have to have a rollback plan. So, crafting a rollback plan is something that I had to learn how to do on the job. And not only crafting a rollback plan, but setting the alerts and proper monitoring, putting that in place to tell me if something broke, right? Beyond just somebody telling you, hey, this doesn't seem to be working, right? Because you got to be proactive in terms of your alerting, in terms of your monitoring. It's kind of, it should, I think, be viewed as like last case scenario to have somebody tell you that something's broken, rather than like you seeing an alert to say like, hey, we're seeing errors on this API. We might have to roll this back to, you know, bring functionality back. That's not something that was even on my radar when I first started this job. Right? I just wasn't thinking about it because I was so laser focused on like writing the perfect code, right? Writing the perfect methods and the most optimized methods. when in reality, sometimes that just does not matter. Micro optimizations are one of the biggest things that hurt developer speed and I think developer quality, because when you start to analyze, like overanalyze your code and try to make all these micro optimizations that just truly just don't matter, that's when you lose speed. That's when scope, you know, when you experience scope creep, that's when you start refactoring stuff that doesn't need to be refactored. And the more code you touch, the more risk you introduce into your pull request. But again, that's not something that I was thinking about, and it's something I wish I was thinking about earlier on in my career. And so I would suggest to you, if you're starting out and you're going to be starting your first job, I would really try to ask people that who you're working with to show you how you can monitor the system and how you can debug in the event that there is an error. And just make sure that you understand the process that goes along with that. And also ask, what is the rollback strategy in place? I think that's a good question to ask, because I think it's important that everybody on the team is aligned with how to do that, and everybody's understanding of the process that has to be followed, so that anybody at any time can roll back if it's not an automated rollback, which I think it should be automated. So obviously, those things were not on my just not on my radar at all when I started out, and nor were they stuff that I thought I was going to be learning on the job. And it was a surprise to me when I got into this career how much of the job truly is not coding and is not software development. A lot of it is configuration. A lot of it is putting in automation for monitoring, alerting. A lot of it, honestly, is just. I don't want to say configuration to make it sound boring, but a lot of it is configuration, because you have to make sure that when your code is is out there running, that it's able to continually be running. Meaning, if we need to scale the instance, can we do that? If we have to roll back, can we do that? Do we have logs in place? Do we have the alerts tied to those logs in place? Are the right people seeing the alerts? Because that's also an important one that you have to make sure you are seeing, right. Um, are the are the right configurations set up for allowing you to basically, I don't want to say, like, in the event that let's say you push a bug out to production, right? You were working on a feature, you're a junior dev, you're making something, it's like your first thing, you push it out and there's a problem. Is there stuff in place that's going to allow you to roll that back? Or if you have to do it manually, you know the process by which you have to make another pull request or whatever and then get that code out of there. However, it's going to be handled. Again, it should be as automatic as possible. But I would just say that when you start out, definitely make sure that you know how to do that stuff, and make sure that your team has an understanding of how to do that collectively, because that's really where the difference is going to be made, right? It's obviously important to meet like deadlines as best as you can, but I think it's bad when you start to rush things and then you start delivering like subpar code that is problematic, and then it causes problems for the system, thereby honestly costing more money than had the feature been delivered a few days later. That kind of analysis is so important, and I feel like it's important that when you start out in this career, you're thinking about it in that way. Meaning, you're thinking about, okay, what's the trade off in terms of, there's always a trade off in terms of speed and quality, right? Because if I push this out a day earlier, is there something that I'm not doing that's going to improve the quality that shouldn't be sacrificed? Whether it's writing a test, whether it's writing or doing load testing, integration testing, or honestly just having another set of eyes to look at your code to make just for a sanity check, because that's important too. This is just not stuff I was thinking about actively. And so if you can, I would try to get alignment as best you can with everybody on your team about these things, right? And never be afraid to ask for like a review of your code. And if it's already been reviewed, to ask for another review from somebody else. Just because the more people you get to look at your code, the better it's going to be in terms of quality, and in terms of just like your overall confidence about not releasing bugs. Um, Now that's not to say like sometimes it can be complicated when you start having a lot of people review stuff because some people look for different things in pull requests, but some people will call out something maybe that's a little bit more subjective than you may would have liked it to be. Um, but I would say that I think that if that's happening on a routine basis, that just warrants like a team discussion about like coding standards and design styles. And I would really try to make the pull requests more focused on like the actual core logic of like, does this actually do what it needs to do? And is it introducing any potential problems or breaking any existing functionality, right? Those are the core things that should be addressed in a pull request. But in again, if you're just starting out, just don't be afraid to ask, right? Don't be afraid to ask somebody, hey, like what are common things that you look for in a pull request? What are things on this team that have happened that we should be mindful of in the future when we look at pull requests? Those are the kind of questions that are good because it gets everybody up to speed on like I feel like some of the more implicit knowledge that kind of becomes embedded in the code, for lack of better words. Um, but it's so important, and especially it's important that everybody knows the kind of the processes of the team, right? Because as developers, we often like to just kind of get focused on our project or our code and make a pull request and then move on to the next thing. But that's only about half the battle, right? That's 50% of the task. The other half is making sure that it gets released correctly and that it is performing correctly and then we're seeing success from it and everything. That's the other half of complete. And that's why it's so hard to quantify how much work can be done because it begs the question, when is it done? Is it done when it goes out to main? Is it done when it gets at the main branch? Is it done when it gets pushed to production? Or is it done when it's validated that it's working as intended? And that might not happen for who knows how long. So it really begs the question of what constitutes done. But that's something to also ask on a team to make sure that you're all in alignment of, okay, when can I actually, when can I actually call it a day on this task, right? And how is that going to affect our how much work we can take on for a given sprint? Because some people are going to look at it, as soon as it hits a certain column, boom, it's done. We can check that off and we can add 3 more points to the sprint and increase the velocity, whatever. Some people are really big on that, and that's typically more of like the planners, not the developers who are going to be in that mindset because the developers know that there's still 50% of the work left to be done. And that's where it becomes challenging to convince people that there might still be some lingering things that might have to be done that sometimes just can't be accounted for in a quantifiable way by way of points. It's very difficult, and that's why it's planning for software. That's why there's a lot of books written about it because there's no one right way to do it because it varies so greatly depending on what the context of your application is, what type of programming it is, who the users are, how often it's used. It varies so greatly, and it's next to impossible to truly estimate with I would even say like 70% certainty of what your sprint velocity is going to be. It's super hard. So we try to do the best we can. It's an educated guess, but as developers, we know that code is all connected, and sometimes there are unintended consequences when you start adding stuff, refactoring, and we know that when we push it out to the main branch, that's 50% of the work, and we still have another 50% left. So I would try to be thinking about some of this, be thinking about the questions that you want to ask your team when you start. And honestly, if you're on a team already, just maybe you can get more alignment on like key issues and processes and what constitutes done and how you can do pull requests better. things like that, just to talk about with the team and get everyone up to speed on, where we should be. So thank you all for watching. I'll see you in the next one.